We are continuing to talk about quadratic functions. We are on slide 8 with graphing. So whenever you graph quadratic functions, we can use several different characteristics to graph it. So axis of symmetry would be one, the vertex, the y-intercept. So if you have forgotten any of those, what they mean, then you will go back to your unit divider, and we have all of our vocabulary words already on there for us. So the vertex, that is the point where the parabola changes direction. So if it is an upside down parabola, one that is going downward, this is your vertex. It's the maximum point. Now, if it is a parabola that is going upward, your vertex is the lowest point, your minimum point. It's the point that it changes direction. So think about a roller coaster. If you're going up the hill and then you get there and then it starts taking that downward turn, so that is your vertex. Same thing if you're coming down the hill, you hit the bottom and then you return and go back up. Axis of symmetry is a vertical line that divides the parabola into two congruent halves. So if I have an upward parabola, it's the vertical line that cuts it in half, and it's always written as x equals some number. Because it's a vertical line. It has an undefined slope, so it's x equals some number. And then our y-intercept, I don't believe it's on here, but the y-intercept is where it crosses the y-axis. But then we have zero, solution roots, and x-intercepts. They all mean the same thing. You need to know that they are all represented by the x-intercept where it crosses the x-axis. They're all the same. So let's look back at our slide. We were working on this example in the last class, so I'm going to zoom in on that example. We had written some things down in our journal. We're also going to look at our calculator too. So our axis of symmetry, we had found the axis of symmetry using that formula, negative b over 2a. So if we look back over at our notes, it came out as x equals 0. So let's draw that. Do we have? Oh, we have a line that we can use. So drag one of those little yellow lines over. We need to put it on, where did it go? Okay, there we go. We need to put it on the y-axis, and that's where x equals 0. I'm going to scoot it up a little bit. Scoot this down so it fits. So that's our axis of symmetry. It's going to cut the parabola in half. And then we found our vertex by plugging in x, the x value from our axis of symmetry, and solving for y. So it came out as 0, 3. So let's plot that point 0, 3. And our y-intercept is also 0, 3. Since this a value, the number in front of x squared, is positive, there's not a number there, so we know it's 1, it's positive. That means it's going upward, so it's going to be the U shape that goes like this. Let's go ahead and write our axis of symmetry, x equals 0. Then our vertex is 0, 3. Our y-intercept is also 0, 3. Okay, we need to do our domain and our range. So we need to get a couple of more points. In order to get a couple more points, we can use our calculator or we can plug in values. So I know this is my vertex, and it's going to be symmetrical on both sides. So I'm going to plug in a 1 here. I'm going to plug in. So I know 0, 3. I'm going to make a table of values. So I know 0, 3 is there. I want 1 over from the vertex. So over would be 1. And I'm going to plug in a 1 here. If I plug in a 1 here, it'd be 1 squared plus 3. And what would that be? It'd be 4. And we found that by doing 1 squared plus 3 because we plugged in a 1. So let's plot that point. So over 1, up 3.
Over 1 up 3 or over 1 up?
Over 1 up 4. Yeah. Yes. Over 1 up 4 because our point is 1, 4, right? So here's our origin. We go over 1 up to 4 and put a point. And so for this parabola to be symmetrical, we're going to have to mirror this point to the other side. So I'm going to take this another point and mirror it to the other side. So see how this one is 1 unit away from the axis of symmetry? So on the other side, it's 1 unit from the axis of symmetry. We're mirroring it. Let's find another point. So I want to go 1 more over. So I'm going to plug in a 2. So now 2 squared plus 3. 2 squared is 4, plus 3 more is 7. Do we have enough spaces for that? I believe so. So go over 2 and up 1, 2, 3, 4, 5, 6, 7. And then we want to mirror this. So where is the mirrored point going to be? Negative 2, 7. Exactly. It's 2 units away from the axis of symmetry, so you go 2 units on the other side. Okay, we need to draw our parabola now because those are the only points that could be graphed on here. So we can use, I'm not sure if we can use the curve tool or scribble.
Yeah, I think there's one on the right side.
Yeah, with your points.
Do what?
You guys one over there with your points.
Oh, there's one over there? Oh, awesome. Okay, great. Thank you. There we go. I'm going to extend it out a little bit. Okay, now our domain. Domain is the x values. What is the domain of this? What can the x values be?
0, 1, 2.
It can start at 0, can go to 1, 2. This arrow means it's going to continue to go on and on forever in both directions. So how would we write that? Negative infinity, positive infinity, or all real numbers? And then our range is our y values. So we look at the y-axis and we see how far down we can go and how far up we can go. So the range would be going down. The lowest it can go is 3. And it goes up from there. So y has to be greater than or equal to 3. Give the maximum or minimum value. So that is our vertex. So this would be the 0, 3. And what is it? Maximum or a minimum? Minimum. So we need to circle that or underline it. I think I can just underline it. It's a minimum. So I just underlined minimum so that we know it is a minimum value. Then our last question, how many root solutions, x-intercepts are there? How many times does it cross the x-axis? 0. So how many are there? None. Okay, that is all the notes we're going to do today. Tomorrow we will work on finishing slide 8 and slide 9. So you have an assignment today, and I will share that with you.